So, welcome students. We have already started our Prelims Masterclass in which we are already covering current affairs portion of your last 1.5 year. So, already polity has started, it's already completed too, economy completed, environment is continuing, and today I'm starting with science and technology portion. Okay. Now, all these articles from last 1.5 years, we have segregated those topics, all the important and relevant topics which we consider from the exams perspective that we are taking up over here. And we have structured them in a theme-wise manner. So that will make your understanding better and you will remember stuffs because of that structuring. Okay. And if you have any doubts, you can ask in the comment box. I'll try to answer each and every comment. Okay. So before I start, just a brief notification about the admissions in Narayana's Academy. We have our 1 year course and 2 year foundation course which has already been launched. And if you want to take admissions, you can go for the details. If you go for the link in the description box, you can click on that and you will see all the details regarding these courses. Okay. Now, before we start, let's look at the trend. Okay, after the trend, I'll directly start with the current affairs topics. First of all, see the trend from science and technology portion from the last 10 years of prelims questions. So if you see all the papers from last 10 years, we have observed there are 27 questions from the basic science portion. Okay, and 79 questions from science and technology portion. So obviously this portion becomes important for us. More questions are coming from this side rather than the basic science part. Now basic science would be whatever you study from your NCERT textbooks. Now if I go in the detailed part, this basic science part, it includes these topics. Let's say microorganisms, cell biology, human biology. So there's one question from human biology in human body in last 10 years. Space science, they have got 8 questions. Applications in everyday life, whatever science you are studying, application in everyday life, 5 questions. Then properties of matter, immune system, heredity and evolution, and diseases. Now, if you look at this trend, you get a basic idea that UPSC might be focusing on these core themes. So if there is any article in the newspaper which relates with these themes, then that becomes important for us. Okay. Then those 79 questions which came from science and technology portion, you see all these themes. So space technology, total 11 questions. So space technology remains in news. For example, ISRO has launched something, NASA has launched something. All that will be part of it. And there are 11 questions in last 10 years. So you can expect almost one question every year, right? Then you have electronic devices, communication technologies, 8 questions from communication technologies. So information technology, ICT, which you say. All this becomes important. Then you have biotechnology, one of the most important sections from prelims perspective. You see 17 questions asked in last 10 years. That means almost 2 questions are coming from biotechnology. Okay, so one of our lecture will be focusing specifically on biotechnology and all the major articles which were there in news from The Hindu or Indian Express or any other newspaper. Then we have health related developments, 2 questions, defense, 4 questions, energy, 4 questions, nanotechnology, 3 questions, governance in science and technology, 2 questions, and some miscellaneous themes. Like there will be some technologies, we're not in a position to categorize them specifically in these themes, so we'll keep them as miscellaneous. Okay. Now see, this trend analysis is highly important for us now to see that whatever we study, we should align our preparation from these themes perspective. So what I have done, all your current affairs of last 1.5 years, I have structured and I have categorized them in a theme wise manner in the same. So what we'll do is, today we'll first start with this energy related technology. Okay, energy related technology, we'll start with this. Then we'll study the nanotechnology part also. So whatever articles we see in the news from this section, this we are going to study now. So first, energy technology. Many questions have been asked from this section. Now you see, in the last 1.5 years, these are the major articles which we see in the news. One is related to uranium enrichment. Second, tokamak technology. Third, fast breeder reactors. Fourth, coal gasification. And fifth, fuel cell technology. Now see, interesting thing. If I look at all these three articles, first three articles, all three are related articles and they are related to nuclear technology. So what we'll do? We'll study these three articles in one go so that we get a complete structure and we understand this theme of nuclear technology completely. Okay, and then this coal gasification and fuel cell technology, this part we'll study separately or independently. Clear? Okay. Now, time to start with the first three articles from nuclear technology part. Now see, look at the relevance from the previous year question. You see this question asked in the year 2018. The question talks about what is the implication of ratifying additional protocol with the International Atomic Energy Agency. Now see, IAEA is an important agency, and the news which we are going to study right now, the first article of uranium enrichment, well, that news has also come from the same agency, that is IAEA. So you can understand why this article becomes relevant. And then we have this question asked in the year 2016. India is an important member of International Thermonuclear Experimental Reactor. In short, we call it ITER. It's a very big project. Now the question has been asked on this project, and when we are studying this tokamak technology article, there also we are going to talk about ITER project. This is a related thing. Okay, so now you can get an idea how these topics, why I have picked them, because I see the relevance in the previous year questions. Okay, so the time comes to start with our first article of the day. The first article is about uranium enrichment. Why it is in news? Iran has started to begin or enriching uranium with thousands of advanced centrifuges. This is what IAEA is saying. Now, to understand this news, we need some basic. We need to understand what is this uranium enrichment. Now, when we talk about uranium enrichment, this news is specifically talking about nuclear weapons being made by Iran. So, uranium enrichment is all about or is related to nuclear energy or production of nuclear energy or nuclear weapon. Now, to understand this entire theme, first we need to understand some basic part related to nuclear energy. You look at nuclear energy, it's considered to be one of the strongest energy that can be stored anywhere. So if you compare it with any other energy, let's say you're comparing it with gravity or any other force or any other energy, I'll say nuclear energy is one of the strongest. And where is it stored? So you look at any atom, you look at the nucleus of that atom. In that nucleus there are protons, neutrons, etc. So in that nucleus, this energy is already stored. Now, if you try to break this bond, protons, neutrons are there, and there is energy stored over here. If you make any changes in this nucleus, then lot of energy will come out. So, how we can do that? We can go for nuclear reactions. So, there are two types of nuclear reactions. One is called as nuclear fission, and other one is called as nuclear fusion. These are those nuclear reactions wherein we are making some changes in the nucleus, and as soon as you make that change, you will get lot of energy, immense amount of energy will come out of it, and we want that energy. Well, we can use that energy to generate electricity, just like we have thermal power plants. We use the coal, we burn the coal to get energy, and through that energy we are making electricity. Or we can use the same energy to make some kind of a bomb, like the nuclear bomb, atomic bomb which you call, or even the hydrogen bomb which you call, right? Same energy can be utilized. Now, to become more specific about these nuclear reactions, you should have a brief idea about these nuclear reactions, nuclear fission and nuclear fusion. What we do in terms of nuclear fission, we take one nucleus. Okay, let's say we have taken uranium. Okay, we have taken the nucleus of atom of uranium. And now we are splitting it, we are dividing it into two parts. There is one nucleus, now we have splitted it into two nuclei. So when you are doing this process, I'm saying lot of energy will come out. This is what we call as nuclear energy. Okay, so this is the nuclear fission process, and this process is very commonly used in the entire world. You see, we have nuclear power plants in India, also in any other parts of the world. You have nuclear power plants, commercial nuclear power plants. There we're using the same uranium, and we are going for nuclear fission through which we are getting electricity. This is very common. Or if I give you the example of the incident of Hiroshima, Nagasaki, the atomic bomb that was used over here, that also included the same process or same reaction, that is nuclear fission. So we understand this process gives a lot of energy. We know the incident of Hiroshima, Nagasaki, right? I said this is one of the way through which you can get nuclear energy. Other way is to get it from nuclear fusion, and it is exactly the reversal. Instead of splitting the nucleus into two parts, here we are going to fuse them. Fuse means you are combining them, you are joining them. So you take nucleus number 1, you take nucleus number 2, and now you are trying to combine or join them. You make it one nuclei. And here when you do this process, here also you get immense energy. Now, one thing we need to understand, if you compare nuclear fission and nuclear fusion, I'll say we get more energy from nuclear fusion. Let's say from fission you are getting this much, from fusion you will get that much. Somewhere we can say 4 times or 5 times the energy of fission we get in nuclear fusion. So it's very simple. We can say nuclear fusion is the best way to get lot of energy, and we are not getting any carbon dioxide, any emissions as such, just like thermal power plants. So it's good, it's very good, it's a clean source, we can say, right? Now this is the basic part. Okay, now in this particular article of uranium enrichment, we are going to focus on this nuclear fission and not the fusion. Just look at this nuclear fission part. Now when you are doing this nuclear fission, you have taken uranium. Okay, uranium is a element, a natural element. Now when you look at uranium in the natural form, let's say you have got uranium from some place, naturally you have brought it over here. If you look at this uranium, it includes two parts. One is called as uranium 238, other one is called as uranium 235. See, these are called as isotopes. Isotopes means is the same element. Whatever uranium I have got, 99% of it is called as uranium 238, and just 0.7% is your uranium 235. These are isotopes. Isotopes means is the same element. Both are uranium, but the number of neutrons in their nucleus are different. It might be having different number of neutrons, it might be having different number of neutrons. Here you can see in uranium 238 protons are 92, in uranium 235 protons are 92. Protons number is same, that means it's the same element, but number of neutrons over here 146 and here 146. So because of neutrons, number of neutrons, what will happen, this element will either become heavier or lighter. If more neutrons are there, it will become heavy. If less are there, it will become light. Okay. Now see, uranium 238, whatever uranium we are getting naturally, 99% is uranium 238 and only 0.7% is uranium 235. Now we have a problem. What is the problem? I'll say this 99% part, this part is useless for me, and only this 0.7% is useful. When we are going for nuclear fission process, I only need this uranium 235. I am not interested in uranium 238. Why? Because when we are going for nuclear fission process, it's not like any element can go for this nuclear fission process. There will be some elements which will go for it. So those elements which can go for nuclear fission and they can sustain this reaction for a long time. There will be a chain reaction. Only those elements are called as fissile materials. Okay, we use this term called fissile material. Fissile means it can go for nuclear fission process and sustain this long chain reaction. Continuously that reaction will go on and nuclear energy will continuously generate it. Now see over here. This uranium-238, it is non-fissile. It's useless. It cannot go ahead with nuclear fission process. And only this uranium-235, which is just 0.7%, this will provide us with nuclear energy. Okay. Now comes the role of uranium enrichment. Whatever Iran is doing or whatever many other countries have already done is uranium enrichment. This enrichment means we will increase the portion of uranium 235 and reduce the portion of uranium 238. Simply 99% is 238 and just 0.7% is 235, right? What we'll do is we'll make this 60%, make this one 40%. So we have increased the portion, or we can make it 60%, make this 40%, or maybe we can reach to a condition wherein we have 90% portion as uranium 235 and just 10% as uranium 238. Isn't it very good? It is very good. This is where we see uranium enrichment process. Whenever we are increasing the portion of uranium 235, which is a fissile material which can go for what we call as nuclear fission process. When we increase this portion in the uranium, that process of increasing is called as uranium enrichment process. Is this clear? Now, obviously, if you have this normal uranium, normal natural uranium, you cannot make nuclear energy. You need more uranium 235. That means you will have to go for uranium enrichment if you want to generate energy. You will have to go for it. Now, first we have only 0.7% uranium 235. Now we will increase the portion. How much we are going to increase? We'll make it 5%. 5% is your uranium 235 and 95% is uranium 238, which is useless. If we increase it to 5%, now we can use this uranium in our commercial power plants. So whatever electricity we are generating from our power plants, there we enrich uranium up till only 5%. Okay. Now let's say scientists want to do some kind of experiment in the laboratory, some kind of experiments for which they need energy. So there, what scientists do, they go for enrichment up till 20%. 20% enrichment. That means uranium 235 is 20% in this uranium. Okay. But in case there is a country who wants to make nuclear weapons, like nuclear weapons or atomic bombs we call it. If you want to build that, you can't make it using just 5% or 20% enrichment. You need at least 90% enrichment. That means the uranium that you are using to generate this much energy, it should have 90% of uranium 235. So you have to enrich it till this stage. Only then you can make nuclear weapon. Otherwise you cannot. That means even if Iran is having uranium with it, and if it is not in a position to enrich it till this stage, it cannot make nuclear weapons. Okay. So right now what news we study over here is Iran to begin enriching uranium with thousands of advanced centrifuges. So Iran is actually going beyond these limits. Whenever we observe any country who is enriching uranium beyond 20%, beyond 40%, beyond 60%, if this is the trend, we can be assured that this country is trying to make nuclear weapons, right? So this is what we are observing from this news. This UN agency or this IAEA is saying that Iran is going for enrichment process beyond the normal limits. and that's why it is a concerning news. Okay. Now in this they have also used one more terminology, that is you're doing this enrichment using advanced centrifuges. So we should know what is this centrifuge all about. So whenever a country is going for uranium enrichment, the enrichment process can be done in multiple ways. What is enrichment? You are just increasing uranium 235 and you are reducing 238. So that can be done through different ways. One of that way is using centrifuges. Other one would be to use gaseous diffusion process. What is centrifuge? Simply, it's a normal device. It's a device very similar to your washing machine, wherein the cloths are moving, right? And in that movement, cloths are getting washed. Now, here in this centrifuge, what will happen? We will use uranium hexafluoride gas, and the centrifuge is going to spin, just like the washing machine. It is going to spin. Now, when it spins continuously, the uranium 235, which we like, it gets concentrated in the center, and the 238 uranium 238, it will keep on moving away. We need uranium 235, it's getting concentrated, and from there we'll get more uranium 235. Okay, this is one way you can enrich uranium. Many countries in the world, they go for using centrifuges, and if you observe this gaseous diffusion, this is not used much, although it also goes for similar kind of mechanism. So they make use of a membrane. Now there is a membrane just like a sponge, from which some part will move away, some part will not move away. So here lighter uranium 235, it will diffuse faster and get concentrated at one location. Okay, but I'm saying this gaseous diffusion is not mostly used. It is this centrifuge which is used by countries. Is this clear? So from this news we are clear that what exactly Iran is trying to do. Now we are still not done, because this IAEA agency, International Atomic Energy Agency, they have specifically mentioned two nuclear facilities from Iran, Fordo and Natanz. So you should know where they are exactly located. In Iran, over here you see this Fordo facility, and here you see Natanz nuclear facility. So these are those power plants or facilities or laboratories you can call, where Iran is trying to do this uranium enrichment. Is this clear? Please remember these names, Fordo and Natanz, that they are in Iran. And this is how I can say we have covered this first topic completely. Please ask if you have any doubts. Anil says, dear sir, kindly provide science and technology current affairs only from The Hindu and Indian Express. Yes, we have taken from Hindu and Indian Express. That's the major source I can say. But there are some news which come from PIB. That's a government source. So we can't neglect that portion also. Okay. Then Ram Kumar Alwala. Hi sir. Hello. Okay. So we'll continue. Any doubt with this first article? Because we'll head towards the next one now. No? Okay, we'll move forward. Now see, the second article. Now this second article talks about tokamak technology. See, in the first article we discussed about nuclear fission process. In this article we'll discuss about nuclear fusion, the second type of reaction which I was talking about. When we talk about nuclear fusion, I said that we'll take two different nuclei and we'll try to fuse it together, combine together. Now this process of combining and making a new nucleus from where we get lot of energy, This process is already common on sun or any other stars in the universe. You look at sun. In the core of the sun, this nuclear fusion is continuously taking place. So it's taking hydrogen and converting this hydrogen into helium. So hydrogen, so they'll take isotopes of hydrogen and then they'll go for the process of fusion. So one nucleus, this will be combined and form the larger nucleus. And that's why from the sun, we are getting a lot of energy continuously because this nuclear fusion is continuously taking place over there. Now, as I said, most of the countries, whatever nuclear power plants they have, whatever electricity they are generating from nuclear power plants, they're making use of nuclear fission process and not this nuclear fusion process. Why? Because nuclear fusion is not that easy for us to make, to take place over here. See, in the laboratory, let's say in this room, I try to go for nuclear fusion process, which is obviously taking place on in the core of the sun. I will need very high temperature in million degrees Celsius, which is there on sun. I need million degree Celsius temperature over here. Now, if I do this experiment over here in this room, entire room will burst, right? Everything will burn. You can't see anything over here. So, sustaining this reaction, doing this reaction at a particular place or in any device, because if you take any device, whether that device is made up of gold, aluminium, whatever, because the temperature is so high, million degrees Celsius, this device itself will burn. So it's very tough to make a device which can sustain nuclear fusion reaction. That's the reason no country in the world is still in a position to say that we have completely built nuclear fusion facility and we are generating a lot of electricity. Countries are still working on this project. India is also working on this project. Many other countries are doing this. And there is an international project also which is going on wherein many countries together are trying to make a device which can sustain nuclear fusion reaction. Why? Because nuclear fusion will give us so much energy that you don't need any other source. Okay, you don't need any other source. You will get so much energy. Our problems of electricity will be sorted out completely. You don't need to depend on coal or any other source. Now, this is the basic part. Now, when I say if there is a country who is trying to do this nuclear fusion at their laboratory, they need to make a device which can sustain this reaction. They need to make that device. And the name of that device is tokamak. So what is tokamak or what is this tokamak technology? Here you are making a device. So here we are making a device which is called as tokamak. The name, actually it's a Russian name. Complete name is toroidal chamber with magnetic coils. Okay. Now, how it exactly goes for this process, how it ensures that whatever nuclear fusion process is going on, it is going to sustain it. Now, this is a technical part which we have to study. Before that, look at this thing. Why we are studying it? Because South Korea has recently said that they have made an artificial sun. So they have actually made not the artificial sun, but rather a tokamak. Because the process over here is similar to sun, that's why we are calling it artificial sun. So any country who makes a tokamak, they'll say we have made artificial sun. Okay. Now the technical part, how this tokamak exactly works. First of all, we need very high temperature if you want to go for nuclear fusion, million degrees Celsius. Now see, if you have something in solid form, if you increase the temperature, if you give it more heat, after some time it will become liquid. Now if you give more heat to this liquid, it will turn into gas, right? But what will happen if we give more heat to something which is in gas form? So if you give it more heat, that million degrees Celsius heat, this gas will turn into a new form which we call as plasma. Okay, this is the next state of matter. Now when we are going for nuclear fusion, we also need this state of matter, that is plasma. So we have to create plasma state over here. This is the first step. Now as I said, on the sun, we take hydrogen, means in the core of the sun. hydrogen is getting converted into helium through the same process of nuclear fusion. One hydrogen, second hydrogen, they are getting fused. It's not the real hydrogen, it is its isotope. One isotope is called as deuterium, other one is called as tritium. For the basic understanding, we can call it, this one is also a form of hydrogen, this one is also a form of hydrogen. Now they are going for nuclear fusion. Those two nuclei are going to combine and become one. That one will be your helium. Okay. Now here we have raised the temperature very high to create this plasma state. To create that plasma state. Now when something is in plasma state, when the temperature is so high, you take any matter, when it gets into this plasma state, it becomes very different. First of all the particles inside it will become charged particles, electrically charged. So there will be positive charge, negative charge, whatever. So some kind of electricity flow will be possible over here. Okay. And if something is having electrical charge, that can be controlled using magnets. This is a fact. We can control it using magnets. Okay. Now why I'm telling you this fact? Because you see, if you look at this tokamak, let's say I'm doing this nuclear fusion process over here in this tokamak device. Even if this gets into the plasma state, temperature very high, all this fire will come here and entire device will burn. Because this device, whatever is the material of this device, it is going to burn at this temperature, million degrees Celsius. So what I want to do is, I want to confine this process only till this part. I don't want this plasma to reach to this walls or chamber of this particular tokamak. I don't want it to reach over here. I want it to remain confined here. And to confine it here, I'll have to attract it. Just like we have gravity on Earth, because of which we are staying here. If you look at sun, that nuclear energy which is getting generated over there, the sun is having gravity, very strong gravity. Here we don't have any such thing. So I will use magnet. Using magnet, I'll try to confine it. And how this magnet will work, or why magnet will work? Because it is in plasma state, it's charged, electrically charged. We can control it using magnets. That's why now we can use the magnets and control this process over here at the center. Clear? So first we created plasma, then we had gone for this magnetic confinement. As far as this plasma was being created, I told you we have to increase the temperature very high. So for that also we have different technologies. For example, we have neutral beam injection, we have radio frequency heating. These are the methods which are used to increase the temperature, to give more heat. That heat is somewhere around more than 100 plus billion degrees Celsius. Okay, just try to remember these names, or these methods: neutral beam injection or radio frequency heating, etc. Okay, now this nuclear fusion will take place. Deuterium and tritium will combine and form a new thing called helium. And when this reaction will take place, I said lot of energy will come out. Some neutrons will also come out, but lot of energy, and we are interested in this energy. We're interested in this energy. We'll use this energy and generate electricity. Okay. This is the process through which tokamak works. This is the process through which tokamak works. Okay. Now I said there are many countries who are trying to build such tokamak device. Many countries are trying. This is a Russian name, that means Russia actually started working on such project first. But you see, India already is running many projects. For example, we had this Aditya tokamak. It was commissioned in 1989. Now we are creating that plasma. We have to sustain that plasma for a long duration. See, something has got into the plasma state. That means the temperature is very high. Now we have to sustain it because when you sustain it, you're getting energy, you can make electricity, right? How long can you sustain this process? This is where the task becomes difficult. So what India could do with this project, we could sustain this process just for 250 to 300 milliseconds. I'm not even talking about seconds, I'm saying milliseconds. 250 to 300 milliseconds. Then we got this Aditya upgraded tokamak version. This one only for 350 milliseconds. Then steady state tokamak. This could sustain for 450 milliseconds. And then we are still working on the steady state tokamak 2. And this is where we still want that this process of plasma creation and plasma sustainability, it should continue for a very long duration in seconds. We don't want it in milliseconds, we want in seconds or minutes or maybe in hours also. Now you look at the news from South Korea. Why it is in news? Because South Korea is saying they have developed a tokamak. The name of that tokamak is K-Star. And right now they have made a record, a world record, wherein they could sustain 100 million degrees Celsius plasma for 48 seconds. See the difference. India is not even in a position to do it for 1 second, and they have done it for 48 seconds. And they're saying with few more efforts, by the year 2026, we'll do it for 300 seconds. So they'll certainly do a really good job. Now, if they could do this, the entire world is going to learn from South Korea. Okay. I said one more thing, that there is one more project at the world level which is going on, which we call as ITER. This you should know over here. This is a South Korea's individual project, which this K-Star. India is also running individual projects. Many countries are doing. But at the international level, many countries came together to build nuclear fusion reactor, to build a tokamak, a larger one at the global level. And that project is named as ITER, International Thermonuclear Experimental Reactor. Okay, where we are doing this? We are doing this in France. So in the southern France, there is a facility where this all thing is happening. And there are so many countries involved. Total 35 countries are part of it. It includes India, Japan, South Korea, Russia, USA, even China. Even China is part of it. So 35 countries. If this project becomes successful, we are still working on it. If it becomes successful, the problem of energy will be sorted out completely, because we will get enough energy from such device. Is this clear? Nuclear fusion and this tokamak technology. Yes? So this is our second article which we have completed. And because we are doing it in one line, all three articles in one go. Okay. So we'll continue with the third topic, that is fast breeder reactors. Yes, you can ask questions. Anil, Ramkumar, if you have any doubts. Now, the third article is about fast breeder reactors. Now, what are fast breeder reactors? What is the news? India's first indigenous fast breeder reactor begins core loading. Now, neither people know what is core loading, nor they know what is this fast breeder reactor. Okay, so let's go for the basic part first. Whatever energy we are generating using nuclear reactor, that's happening in a nuclear power plant where we have a reactor. It's a device where this reaction is taking place. That's your nuclear reactor. Now, when you look at this process, we can go for nuclear fission process. You can take the uranium and go for this nuclear fission and get the electricity. That's the simple way you can move ahead. But we have a problem. The problem is India does not have enough uranium reserves. You see, in India, we don't have enough uranium. If you want to go for uranium enrichment, first you need uranium. And if you want to generate electricity or energy from uranium for years, let's say for next 30, 40, 50 years, 100 years, do you have enough uranium? Well, we don't. What we do is we import it from other countries. So first of all, we are dependent on those countries. Secondly, those countries, can we assure ourselves that every time we want uranium, we'll get it from those countries? This is something challenging. So Indian government, or rather the scientists in India, they thought about a program. We call it three-stage nuclear power program. So it is a brainchild of Dr. Homi Jahangir Bhabha. He said that instead of relying on uranium, we can look for an alternative source to go for this nuclear reaction. So they suggested, why can't we use thorium? India is having lot of resources or lot of reserves of thorium. But there is a problem with thorium. It's not fissile. It cannot go ahead with nuclear fission. Then what's the use of it? We have got a lot of reserves of thorium, but directly it cannot generate energy for us. Directly it cannot go ahead with nuclear fission for us. But Dr. Homir Jahangir Bhabha, he was a smart person, he said, we can make use of thorium in such a way that we can make fissile materials. We can make, let's say, uranium or plutonium or something that can go ahead with nuclear fission, but we can make use of thorium in that in such a way that we get more uranium or more fissile material. So to understand, you need to know this program completely. So India's nuclear power program is made in such a way or is planned in such a way that we go for 3 steps. We are still working on those steps. Okay. And if we complete the third step, we can say that India will be completely self-sustaining, will become Atmanirbhar in terms of energy. Okay. Because we are utilizing our thorium over here and we have got a lot of thorium. Now, how this will happen? In the first stage, what we will do? We'll build pressurized heavy water reactors. In short, we call it PHWR. So these are normal reactors. Here, first we take the natural uranium. Natural uranium. Natural uranium has just 0.7% of uranium-235, which is useful for us. And rest is your uranium-238, which is not so useful. But we'll take this natural uranium, okay, and then we will go for this nuclear fission process. Now, as a result, we will get some energy or we'll get some electricity, but there will be one additional byproduct that we will get is plutonium-239. Okay, it's not in very large quantity, but at least we will get some plutonium-239. Now, this plutonium-239 is a fissile material. That means you can use plutonium-239 to go for nuclear fission process. So now we'll use this and we'll go for a next step which is called as fast breeder reactor. Now this is the same stage which is in news right now. Okay, fast breeder reactor. First we have taken this plutonium and we have used uranium-238. Do you remember uranium-238? It's not useful for us, it's not fissile material. Still we are going for this reaction because scientists know if you go for this reaction, we get more plutonium. See, if you go for this reaction, here in the input you used plutonium, in the output also you got plutonium, you got uranium also, you got electricity also. But see, if you have given in the input this much plutonium, in the output you are getting this much plutonium. The output is more. The same plutonium which is used over here, 2 times, 3 times, 4 times or 5 times of the same material we get in this reaction. So it is very similar to breeding process wherein someone is giving birth to many children, that breeding process. So that's the reason we have given this stage a name called fast breeder reactor. Okay, so it is breeding the fuel. We need more uranium, we said, or we need that nuclear fuel. So we are increasing the fuel through this second stage. Okay, then when we will complete this second stage, this product, this uranium-233 which was there, now this is also a fissile material. Again, it's not in much quantity, but still we are getting it, right? We'll use this and we'll react it with thorium. Thorium is useless, thorium is not fissile for us. But when you go for this reaction, at the end, what you get is more uranium-233. Now you see, I said uranium-233 is fissile material. It can go for nuclear fission. And by a reaction with thorium, it is giving us more uranium-233. So now we can use this uranium and rely on it. So we started the story in such a way that even if we have very less uranium, we can get very much uranium in large quantity by using our thorium, by utilizing our thorium. And through this entire process, we will have enough nuclear fuel with us. Okay, this is the technical part which you should at least understand briefly. Now India is still working on this. First part we have done. Second, we are working. You see this news item. India's first indigenous fast breeder reactor has started its core loading process. Means we are in the second stage, and in this second stage something called core loading is happening. Okay, what is this core loading and where is it happening? It's happening in Kalpakkam, which is in Tamil Nadu. So in Tamil Nadu we have a nuclear facility where this process is taking place. Now core loading simply means you're putting the fuel in the core part. So let's say you have a bike, you have petrol tank, in that you are putting the petrol, you are loading the petrol. Similarly, this is the core part of this nuclear facility, and here you are loading your nuclear fuel. Let's say this uranium or thorium or whatever which you are adding over here or loading, that is called core loading. Once this fuel is added, that nuclear fusion process will start. So we call this stage as criticality. So we will start this criticality, or we'll reach to this criticality when core loading will take place. That means this news is important news. We can't neglect this news, right? And why we are so much focusing on this fast breeder reactor, that second stage? Because we are creating more fuel. We have less amount of fuel, but we are creating more fuel. So we call it highly fuel efficient part, wherein we are converting fertile material into fissile material. Please don't get confused with these terminologies. Fertile material means it cannot go ahead with fission process. Only this fissile material can go ahead with fission process. But in this fast breeder reactor, we are converting fertile material into fissile material. And we are also utilizing our thorium resources. If we do this, we will become self-sufficient. That's why this fast breeder reactor process itself is very important. That's the reason this news item is very important. Okay, so that was all about this news item. Clear? If you have any doubts, please ask. No? Okay. Now we have already completed 3 topics. Let's say uranium enrichment, tokamak technology, fast breeder reactors, all related to the nuclear technology part. And now we have this coal gasification and fuel cell technology. These two are important topics. As I said, we'll study them separately. So let's start with coal gasification. Why it's in news is because Union Cabinet has allocated substantial amount of money for these coal gasification projects. 8,500 crore rupees incentive scheme for coal gasification projects by Union Cabinet. If they are providing so much amount of money, that means it must be an important stuff. But how much important we'll understand over here. Look at this previous year question. I'll give you 5 seconds. Please read this particular question. Okay, please read. Done? So if you read this question, you specifically understand that UPSC is asking question on coal. Coal ash contains arsenic, coal-fired power plant, they release sulfur dioxide, high ash content is observed in Indian coal. So coal becomes important. Now if you look at the science and technology part, or if you look at India's dependence on energy, you'll see that 50% or more than 50% of our electricity is generated from coal-based power plants. We are dependent on coal. That's the reason even UPSC is interested in coal. Okay. Now, this process of coal gasification, it is very interesting. So we are actually using coal and we are converting into a kind of gas. Normally, coal is in solid form, and now we are trying to make a gas out of it. And why we are doing it? Because we want a better fuel than coal. We don't like coal. We want something better than coal. So here is a concept called calorific value. Concept of calorific value which you need to understand. You see, I'll give you one example. Let's say I have taken 1 kg, 1 kg of coal and 1 kg of petrol. Okay, so the amount is almost the same, 1 kg, 1 kg. Now if I burn this coal and if I burn this petrol, I'll check how much energy do I get. And after this experiment, I get to know that I'm getting more energy from petrol as compared to the coal. Okay, now this, when we are calculating, when we are checking how much energy do we get by burning a particular fuel of the same quantity and we compare it with other fuels, then actually we are checking its calorific value. Okay, so if you burn coal, 1 kg coal, you will get somewhere around 25,000 to 33,000 kilojoule per kg calorific value, or this much amount of energy we are going to get if you burn coal. Okay, this is the unit that we use to measure how much energy we are getting, 25,000. And if you burn the same amount of petrol, that is 1 kg of petrol, you get 45,000 kilojoule per kg of your energy. That means petrol is better. Same amount of fuel you use and you get more energy. Compare petrol with, let's say, methane. If you burn 1 kg of methane, you get 50,000 kilojoule of energy. That means methane is way better than petrol or way better than coal. And at last we have here hydrogen. If you take 1 kg of hydrogen and burn it, you get 1,50,000 kilojoule of energy. That means hydrogen is the best among all of these. Don't use any other fuel, use hydrogen, because it's going to give you more energy than any other source. So we are understanding all of this through the concept of calorific value. That calorific value of methane is more, of CNG is more, LPG is more, hydrogen is more. You understand this? And comparatively, the calorific value of coal is very less. Now there is one more problem with coal. When we are dependent on coal, when you burn coal, you get carbon dioxide. We get those harmful gases which we do not need. Because of this carbon dioxide, now we see climate change, global warming, all these phenomena taking place. So we don't like coal as such. We don't want to use coal. We are dependent, but we don't want to use it. So one of the way is to change this coal, to turn this coal into something new. And for that we use this process called coal gasification. We are gasifying it. It is in solid form, we are converting into a gas form, and that gas is called as syngas. Syn means synthetic gas. We are artificially doing this or making it. So it's a synthetic gas. Now when you convert coal into synthetic gas, we get this new gas which you call as syngas. Now it's not a single gas as such. It's not like syngas is a particular gas as such. Actually it's a mixture of many gases. So the syngas includes methane, carbon monoxide, hydrogen, carbon dioxide, water vapor. All these things are mixed together and overall we call it syngas. Okay, so first we took the coal and we have converted into syngas. So we got these many things as part of the syngas. Now see, it has got methane, it has got hydrogen. So in the last slide I told you, methane and hydrogen, they are way better than coal. So instead of using coal, use methane and hydrogen as a fuel. So you will not rely on coal also, and you are utilizing the coal also, and you are not going for any kind of emission as such. Very good. So that's why we say when you use this syngas or when you go for coal gasification project, where you make this syngas, we are actually going for a cleaner energy source or alternative source for making electricity. Instead of directly burning coal, convert it into syngas, use that methane, use that hydrogen to generate electricity. Cleaner way to go for it. Then here is hydrogen, you can purify it, you can get this hydrogen, so hydrogen production will take place. You can also make some synthetic fuels out of it, like this methanol, gasoline. All these can also be made using this syngas. Okay, so we understand, yes, coal gasification is a good thing. That's the reason government is giving incentives to start such projects for going for this coal gasification. Okay, any doubt till now? No? Okay. Now, when you look at this coal gasification process, if you look at the technical aspect of it, although I don't expect UPSC to go in details of it, but at least the basic part we should be aware of. Sometimes there will be statements which includes these words. At least the basic idea, you should have the basic idea how this process exactly happens. So first we take one device. That device is your furnace. So this is your furnace, and we'll take the coal which is in solid form and we are going to inject that coal over here in this furnace. Okay, it has entered. Now first thing that we will do is evaporation or drying. Now, the coal that you have taken, that coal has some moisture content in it. Okay, some water part, some moisture part which is already there in the coal. Now we are trying to remove that moisture. To remove, we'll go for evaporation process. So here all that water part will be removed. Then we go for devolatilization process. See, there are some materials called volatile materials. There are some materials called volatile materials. You look at petrol, you take some petrol over here, you'll see that after some time you won't see any petrol. Why? Because it is getting evaporated very easily, very quickly. So there are some materials which we call as volatile materials. They'll get evaporated at the room temperature very easily and very quickly they'll get evaporated. So after some time you will not see that material over here. Such things are called volatile material. They are so volatile. Now here in this coal, there are some volatile substances in this coal and we are trying to remove that volatile substance. So this process is called as devolatilization. Devolatilization. Okay. After that we go for oxidation process. So simply carbon, this coal is having carbon part. This carbon is going to react with oxygen to form carbon dioxide. Also there will be some heat generated in this process. And then the last process of reduction and pyrolysis. Reduction is exactly the reversal of oxidation. But the next stage is pyrolysis, and pyrolysis is very important. I want you to remember this pyrolysis stuff. What is pyrolysis? Here we are burning this coal. We are burning this coal without oxygen. Without oxygen. This is very important. Normally, when you look at our new power stations or power plants, there we are using coal and we are burning that coal. But to burn, we are using oxygen. Here I am saying we are burning the coal at this stage without using oxygen. When you don't use oxygen, it is called pyrolysis. And here the temperature will be very high, somewhere in, let's say, 1000 degrees Celsius or something like that. Temperature will be very high over here. This pyrolysis process will complete and at the end you get syngas. So this is a very long process. Coal gasification, which we say, this is a long process. At the end you get syngas and some ash. Some ash will be a byproduct. Okay. So this is a technical part. At least the basic idea should be there. You should have a brief idea. Clarity should be there. And here the news is simply 8,500 crore incentives are given for this. Even in the mains, you can use this as an example. You can quote this government initiative when you're talking about cleaner energy sources. Okay, done. See, 1, 2, 3, 4. 4 articles are done. Only one article from energy section is remaining. Then we'll move towards the second theme, that is nanotechnology. Okay. So last is your fuel cell technology. Very easy and very short. See this particular question already asked on fuel cells. So I don't need to tell you that this topic is important. In 2020, sorry, it's not 2025. Wrongly mentioned, maybe it's 2015. So check that date. But the point is, UPSC has already asked question directly on fuel cell technology, how this hydrogen rich fuel and oxygen are used to generate electricity in this fuel cells. Okay, directly statements are given over here. Please read. I'll give you 5 seconds. Please read. Yes, done. Okay. Now, what is this fuel cell technology and why we are studying about it? Recently, it was in news because ISRO has said that we have tested this fuel cell technology and we are going to use it for our space missions. So whenever we are sending any spacecraft, any satellite or whatever, we are planning to make use of fuel cell technology. Now it's a technology to generate electricity, just like we are generating electricity from coal-based power plants. We're generating electricity from different stuffs, or we are getting energy from one way or the other. If you're going for a space mission, there also continuously you need some kind of energy. See, normal vehicle requires petrol, diesel, without which it will not work. So you're sending a spacecraft, you need continuous source of energy. So fuel cell is considered to be a good source, a very good source, and most importantly, a very clean source. You're not getting any carbon dioxide emission. You're not getting any harmful thing from this fuel cell. That's why it's a very good source. Okay. Now, what happens in fuel cell? We make use of chemical energy and we convert it into electrical energy. Okay, what is chemical energy? Simply, in the molecules at the atomic levels, the energy is stored, and when you go for a chemical reaction, you can bring this energy out. That is chemical energy which is stored. Now you can convert this chemical energy into other forms. See, energy, one thing about energy is very clear, it can be converted into different forms. Now here we are trying to convert it into electrical energy or simply electricity, right? So whenever you look at these things wherein we have protons, neutrons, electrons, when electrons come out, when electrons move, let's say we have a wire, from this wire electrons are moving. Now this movement of electrons itself is your electricity. This is electricity. Okay, so here in this fuel cell, we take chemical energy, we bring this chemical energy which is stored, and we convert it into electrical energy, and that's our electricity. Now how this happens? This is the fuel cell. Okay, there's one thing called anode over here, one thing called cathode over here. Okay, this is the negative electrode, this is positive electrode. So the main thing or main fuel that we need over here, is hydrogen. Okay, in the nuclear one we said uranium is required. Here we need hydrogen. Hydrogen is very easy to get. Hydrogen is present on this planet or in the entire universe in abundant quantity or very much quantity. We can get hydrogen anytime we want. Now this hydrogen will enter in this anode. After entering, see, hydrogen is having protons, is having neutrons, is having, sorry, not neutrons, it is having protons, it is having electrons. Now proton positively charged, electron negatively charged. This is going to get separated at the anode. Okay, at this anode, protons and electrons will be separated, and this electron will move from different direction and proton will move from different direction. Why this will happen? Here we have anode, here you have cathode, but in between you have something called a membrane, or we have a term called electrolyte. This electrolyte is there over here. You can consider it something like a sponge or a filter. Now what this filter or this membrane will do? It will allow the protons to move from this to this direction, from anode to cathode. From this membrane or this electrolyte, protons will move. Protons are positively charged, they will move, but it will not let electrons to move. So what electrons will do? They have to find out some route, they have to go. So they will make their own route. They will go in this direction. They will not use this membrane. They are making their own path. Now this path is itself your electricity. I told you, when electrons move, then that movement itself is your electricity. So automatically electricity got generated over here. Okay, so this is how we say we have converted chemical energy into electrical energy. We got electricity, we got it. But from here we added hydrogen. On this side we have added oxygen to this cathode. What will happen? Protons will reach to oxygen, electrons will also reach to oxygen. So hydrogen and oxygen together they will form H2O. So in simple terms I can say the fuel that we are using in fuel cell technology is hydrogen, and we are using an oxidizer called oxygen. As a result, what we get as a byproduct is, one is your electricity and other one is your water. Is water harmful? Not at all. Water is good. That's why we are calling it a very clean source of energy. Okay, water as well as some heat will also be there. So it's a good thing. Now this fuel cell, it is of many types. Okay, sometimes we have proton exchange membrane fuel cell, it's one of the types. Then solid oxide fuel cells, molten carbonate fuel cells. So these are just different types of fuel cells. Now there will be one smaller one which requires very less temperature. At very less temperature it is going to operate. So this is your proton exchange membrane. So let's say I need electricity at my home, or for some smaller devices or some portable devices, I'll use this PEM, this type. Let's say I'm building something larger. Okay, so there's a power facility, or let's say power plant or backup generator. For that I'll use this one. And let's say I want to go for a large scale power generation at a big factory or a grid power plant, or at the grid I need a continuous power supply. So there I'll use this third category. These two operate at high temperature, this one operates at very less temperature. Okay, this is just basic part or basic fact you should know about the types. Okay, so now you understand fuel cell, how it works, you understand why it is important. Because first of all it's clean and we can use it anywhere. First of all, its application can be observed in spacecraft and satellites. Even already ISRO is saying we are going to use it. NASA is already trying to use it. So many countries will try to use in their spacecrafts this fuel cell technology instead of relying on any other source. Then for transportation, for us, instead of using petrol, diesel, etc., we can utilize this fuel cell technology. So we'll use hydrogen. We will not rely on these petrol and diesel. Anyway, they are causing a lot of problems for us. This climate change, global warming, all these things, right? Then for stationary power plants, like for let's say at home we need some supply, some power backup, at hospitals, at industries, we can use this. And one good thing is it has no noise as such. Normally the power backup we get at home is it's very noisy, right? It's very noisy, but there's no noise, so it's good to use. And it is used as power backup for critical infrastructure. Sometimes we have some infrastructures where we continuously need electricity. We can't compromise on it. Let's say some cyber security infrastructure. If there is no electricity, how are you going to work over there, right? So these are all applications of fuel cell technology. So here I can say, as far as energy technology section is concerned, we have covered all these 5 topics in detail. Okay, I hope you don't need to revise again. You can just, if you want to revise, let's say, just to go through all the topics, just to brush up your facts, what you can do is you can download the Narayana IS application. There you'll get the PPT as well as the notes. All these are provided. Narayana IS application. Okay, you can download it directly in the free material section. You'll get this part easily. Okay, now we are done with one complete theme. So next is the next theme. Yes, Sakshi, hello. Okay, we'll continue in the same manner, covering each and every theme. One theme is done. Second theme that we will start over here is nanotechnology. So in the beginning I showed you that in the trends that nanotechnology is also an important section, and UPSC has been asking questions on this section. So I've got 4 articles from nanotechnology section: nano respirocytes, nano bubble technology, nano bub I'm sorry, maybe it's got repeated. There's one more thing: nanotechnology in healthcare. One more topic, maybe we'll check it. Now see, look at this previous year question asked in the year 2015. So this question is directly focusing on the aspect of nanotechnology which we are using in the healthcare sector. Okay, so targeted drug delivery, nanotechnology can largely contribute to gene therapy. Now this is a part of healthcare, and this is also one of the topics which we are going to cover. And all these parts also, they will be relevant for us. Now see, the first article, nano respirocytes. Now they are very interesting and very easy to understand. Even if the term is very technical, it's very easy to understand and very easy to remember. Now simply you have to look at something called red blood cells which are present in our body. Do you know red blood cells? Where are they located? In our blood. See, if you take our blood includes many things. Blood has got many components. It has red blood cells, it has white blood cells, it has platelets, it has plasma. So many things are there. Out of all these things, one most important thing is your red blood cells. So there are some cells like this. Some cells will be continuously flowing in your blood. Those red blood cells are very important. Why? Because there's something called hemoglobin which is present in these red blood cells. Now what this hemoglobin or overall this red blood cell does for us is, our body continuously needs supply of oxygen. See, our body is made up of many cells. There are so many cells in our body. Each cell needs oxygen continuously to continue its process. Okay, now we get the oxygen through our nose, it gets to our lungs. Now from lungs to every part of our body, this supply mechanism is done by our blood. So we have these red blood cells which actually take the oxygen from lung and supply it throughout our body to each and every part of our body, to each and every cell of our body. Oxygen will be provided. And also obviously there will be some carbon dioxide which has to be removed. So they will take the carbon dioxide and give it to the lungs. Lungs will then give it back to the nose and it will come out. That means this respiration part which we do every day, the body which requires oxygen continuously, carbon dioxide which has to be removed continuously, everything is being done by red blood cells, right? Now just imagine, in case there is a person and that person's body has some kind of problem wherein the red blood cells are not working finely. Let's say the cells are damaged, or there's some problem with the cells, they have become weak, or there's one disease called the sickle cell anemia. Such kind of diseases are there. So any kind of problem is being faced by this person. So there is problem with their red blood cells. Now we can utilize nanotechnology to solve this person's problem. Nanotechnology means we are making some kind of technology and we are operating at nanoscale. Nanoscale means, simply say, let's say we have something of 1 meter. Okay, 1 meter. Now if I take something of 1 meter, I can, just give me 1 second. Let's say something of 1 meter. Okay, let's say I have a stick or something 1 meter length. I can divide it into 4 parts, 5 parts, 10 parts. If I divide it into 1 billion parts, can you imagine 1 billion parts? So that, and if you take one single part out of it, that part we are dealing at nanoscale. So meter, centimeter, likewise you can go at the nanometer scale, which is 1 billionth part. Okay, so we are doing our engineering, we are making our technologies at that smaller level. So just like our cells, can you imagine something is operating at a scale which is even smaller than our cells. Okay, even smaller than our cells. So now we are using this nanotechnology to solve this person's red blood cell related issue. What we are doing? We are making artificial red blood cells. Artificial red blood cells we are making, and this is what we call as nanorespirocytes. These are your artificially made red blood cells. Now we'll do one thing, we'll put this artificially made red blood cells into that person's body, into that person's blood, and they're very small, so they are going to work over here and they are going to act as the red blood cells. Now I said there is a problem with red blood cells, let's say in my body, they are not working. What will happen? Even if I am taking oxygen, that will not reach to every part of my body. So I will take this nanorespirocytes, and this will ensure that oxygen reaches to every part of my body. So even if I am not breathing right now, if there are these nanorespirocytes, see, I am breathing, it is in my lungs, there is oxygen, but it is not utilized. Now it will be utilized because of nanorespirocytes. Okay, so this is the job, this is the major job. Now the basic fact, the size of it, this 1 micrometer. Okay, very small. Material that is used over here is a diamondroid shell. Now it's a red blood cell, and if you see its outer part, outer shell, it is made up of a material which is very strong. You see, if you put anything in your blood, it is not possible for it to survive easily. If it is a normal material, it won't survive. There is very high pressure in our bloods, and because of that pressure, it will get destroyed or damaged. So you need something which is very strong. So the outer core of this material is diamondroid. It's like diamond. So you see diamond, which is made up of carbon, but its structure is of a special kind, which makes it very strong. Diamond is considered to be one of the strongest thing we see on the earth, right? So this material is diamondroid, very similar to diamond. Similar kind of structure is there. So it's very strong. It can resist pressure up to 1 lakh atmosphere. So it's very strong. Okay. And here we are transporting gases like oxygen, carbon dioxide. So oxygen will be transported to every part of our body. Carbon dioxide will be removed from every part of our body. Then if you want to do any kind of drug delivery, let's say a person is having cancer, a person is having some problem with red blood cells or any part of the body, and we have to provide one medicine or drug to that particular part. Normally whatever medicine we take, that goes to all the parts of the body. Now that could be harmful for us. We want precisely the medicine should go to that particular location where the problem is. There we can utilize this respirocytes, so they can reach to exact location and they can deliver that drug over there. Then this part is very important, this is technical part, but you should know. On these red blood cells, artificially created red blood cells, there are no antigens. What are antigens? Antigens are some kind of proteins. You see, you take my blood, I'll say it's A positive. I call it A positive. You might be having AB positive, O negative, whatever. That blood category we are knowing because of one extra protein that is present on the surface of these RBCs. So my blood if you take, and if you take this RBC, on the surface there will be one antigen like this, some kind of antenna or some kind of ID card you can call it. It's ID card. It will tell that this is A blood group. There will be one more antenna which will say it is positive also. So A positive, right? Now, if you give me any other blood which has different kind of a structure, let's say this kind of antigen is present on that blood. If you put this blood in my body will not accept it because this antigen is very different, right? But if you give me any blood which has no antigen, so for example, this O blood group, it has no antigen. If you put this blood in my body will accept it because there is no antigen. There is no antigen. So my body will accept. That's why we say blood group O is universal donor. Now I'm saying when you are making this artificial red blood cell, it does not have any antigen as such. So just like your O blood group, which is universal donor, this respirocyte is also universal donor. Anyone can take this because it has no antigen. So your body will accept it. Okay. And there's something called controlled release. That means it's not like it is going to release oxygen to every part of body at any point of time. It is very smart. Let's say let's say my hand here, exactly at this location oxygen is needed at this point of time, it will provide at that point of time. So it's a smart kind of system that we have. Okay, so this respirocytes, this is application of nanotechnology in the healthcare part, we can say, to some extent. Okay, so what are the medical applications? When you're going for blood replacement, there you can directly use it. Just like, let's say you're not getting the same blood group blood, you use this, you can use this, no issues. You can treat respiratory diseases. Sometimes, let's say you got asthma, pneumonia, lungs related problem. Now if your lungs are not working properly, how come you expect that you will get oxygen? So there also this will be useful, because even if your lungs are not properly working, somehow we can store some oxygen and supply it to your body. This is possible. Then there are some athletes, there are some people who are going for some underwater activities or going for Himalayan high altitude climbing, all these things where there is less oxygen available. In the water, there's no oxygen which you can take. So there you can utilize this thing called nanorespirocytes. Good? Any doubt? We're done with the first part. No doubt? Good. Now the next is nanoenzymes. So this was supposed to be nanozymes or nanoenzymes. First one is done. We are on the second one. Now this is in news, and this is news from the PIB. Nanozymes can transform biomaterials for use in medicinal and biomedical applications. Now can anyone tell me what do we mean by enzymes? Because unless you know enzyme, you can't study nanoenzyme. Yes, anyone? No? Okay. So see, there's something called enzyme which is anyway present in our body. There are many enzymes which are present. Now these enzymes, what they do is, whatever reaction that has to take place in your body, they are going to speed it up. Let's say you're eating something, your food is supposed to get digested. So this digesting process, this has to be speeded up. It will be done by some enzymes. So there are many other processes happening in our body, and there they act as some kind of catalyst. Okay, they act as some kind of natural catalyst which speed up biochemical reactions. These are your natural enzymes. Now we are creating artificial enzymes, that too at nano level, very small, very small, and we are trying to insert it in our body somehow. Let's say we need some extra enzymes to solve some problem, or let's say our enzymes have become useless, they are not working, then we'll use this nano enzyme. And this is not so costly also. Using nanotechnology, making these nano enzymes is not a tough thing. It's very stable, it's very cost effective. And recently this is in news because CSIR CLRI Chennai, they have developed some nano enzymes. That's the reason it is in news. Now it has got applications in many different fields. One application will be there in biomedical field. You see, let's say I've got some cut over here. Okay, now the wound is supposed to heal, and my body has the mechanism to heal it, but I want this wound to heal very quickly, very fast. So whatever natural process happens in my body, to speed it up, there are some enzymes present in my body which will do it. Now in case I got a bigger wound or some accident, in that case, if I want to go for this wound healing process very quickly, I can add extra enzyme. I can add nanozyme specifically in that particular tissue. Wherever I've got the problem, exactly there I can put this nanozyme and my wound will be healed very easily. Okay. Then in our body sometimes there are some bad chemicals released. We talk about some diseases like Alzheimer's or some heart related diseases. So some bad chemicals like this ROS is generated in our body. Now we want to destroy that. That can also be done by enzymes, because there are some enzymes in our body which go for some chemical reaction and destroy things. They can break down things, break down complex things into simpler things. They can do many things, right? So here we can remove or destroy this ROS, this bad chemical, in the patients who are suffering from any heart disease or Alzheimer or cancer. So in the cancer treatment also this will happen. We can deliver drug at precise location, just we did in the earlier earlier article. Similar thing can be done by nanozymes. Then there is application in biosensing. See, let's say in your body sugar content is high, but how will doctor know? They need some kind of sensors, biosensors. So you can use these nanozymes. You put the nanozymes in your body, and because some of them can detect something specific, let's say sugar, they can detect sugar, they can detect H2O2, they can detect DNA. So to sense or detect something, these can be used very easily. So any person who might be suffering from sugar or is very vulnerable to sugar or diabetes, so you can check all these things very easily using nanozymes. Then you have environmental use. You have water which you want to clean. So for the cleaning or purification process, you want to remove those pollutants. For that also you can use nanozymes. As I told you, some enzymes, they can break down complex material into simpler things. So even if there is some pollutant, some contaminants, you can break it down into simple part, and all that waste material will become normal material. Okay, so water will be cleaned very easily or purified. So second is done. Now third is nano bubble technology. These are very easy. These are very short news items. You just need to briefly understand it. Okay, whichever required detailed understanding, I have discussed them in detail. Okay, nano bubble technology. Again, news from PIB, Ministry of Environment, Forest and Climate Change. Okay, what's the news? Union Minister of State from this ministry, they have launched something called nano bubble technology. They have launched this nano bubble technology. So actually it is prepared by your IIT Roper, and they're trying to purify water. Whatever contaminants are there in the water, they are trying to purify it using this bubble technology, nano bubble technology. Okay. Now, what is bubble or nano bubble? Any idea? Now, because you're anyway understanding nanotechnology, so can you give me any idea about nano bubble? No? Okay. Just like any other bubble, this is a bubble, but at nanoscale, very small scale. So you look at a bubble, it's a what we call a kind of balloon or a bubble which has some gas in it. So it is a material made up of water. Let's say normal water, there are some bubbles in the water. So those bubbles are actually nothing but gas concentrated at one location. There is gas in it. There can be oxygen, carbon dioxide, or whatever. Okay. Now we are using such bubbles, but at very small scale. We are not talking about larger bubbles. Any normal bubble which you observe, it will burst in few seconds. But if you're making very small nanoscale bubbles, they are going to survive for a very long duration. So let's say there is some water in which hypoxic conditions are there. There is very less oxygen in a water. Let's say there is a pond over here. There is no oxygen. There is very less oxygen. We want to increase oxygen, because if there won't be any oxygen, you can't expect the aquatic species to live over here. They can't survive over there. We need oxygen. So we can, if we try to inject oxygen from outside, that will come out obviously, that will not remain in the water. So to or to ensure that the water gets that, absorbs that oxygen, or that oxygen stays there for long duration, we can make use of nano bubbles, very small bubbles. Those bubbles will be injected in that water and they will stay there. So the water which did not have any oxygen now will have substantial oxygen over there. Okay, at the molecular level, at a very small level. Okay, and this nano bubble, it has very high stability. There is very high internal pressure also. Those bubbles which we are making, there is very high pressure, because of which this bubble is not going to get burst very easily. It will remain. Okay, and it has large surface to volume ratio. That means there are so many bubbles, so the surface area will be very large. It will be covering entire water. Whatever amount of water you have, all the surface will be covered by these bubbles. Okay, now using this technology, first we can treat the water. Let's say you have best water coming from our homes or factories or anything. This water is very much contaminated. You can improve its quality. So in that bubble, whatever you want to add, you can add. It's not just oxygen. You can add anything and you can put that in the water. So there will be some chemical reaction and the water will be treated. Now the water will be improved. If there is some kind of odor you are getting from water, that won't be there. Then in the agriculture also you can use it. Let's say you want to make improvements in the soil. The water that you are providing to this soil, that has to be improved. If there are some germs, there are some contaminants in that water, you can't expect good agriculture. So that can be treated. Aquaculture part, as I gave you the example of a pond. Similarly, let's say there is a river or there is any aquatic system in which there is hypoxic condition. Hypoxic means oxygen supply is not there or very limited, very less. When the dissolved oxygen in the water is very less, how can you expect the fish to survive there or any other species to survive? They won't survive. So for them to survive, they need oxygen, dissolved oxygen. So that can be provided using this nano bubble technology. Okay, so third one is done. We are left with just one article, that is nanotechnology in healthcare. Yes, any doubt till now? No? So the last article, nanotechnology in the healthcare. So whatever we have studied till now is also somehow relating to the healthcare part. But specifically, we need to understand briefly how nanotechnology is being used in the healthcare part. Okay, so this basic part I've already discussed about nanotechnology. You see the different generations in which nanotechnology is being used. Initially, when scientists started using nanotechnology or developing, they used it at a passive scale. So they used some materials at nanoscale, very small. They started putting in our body or anywhere. Let's say they started making some. See, we have been making some chips at very small scale. So just you can imagine some materials made at nanoscale. Okay, so let's say for example titanium dioxide nanoparticles being used in sunscreen. You use sunscreen, so normally when you read any advertisement they say that our sunscreen will protect you from UV rays. Now UV rays are anyway coming. To block them, you need this titanium dioxide. So what we did, we took a sunscreen and we have put nanoparticles of this titanium dioxide. So when you apply this sunscreen on the face, entire face is anyway covered with the nanoparticles of titanium dioxide. So if UV rays are coming, those will be blocked. Okay. So, but this we call as a passive method of using nanoparticles. These particles themselves are not doing anything. They are not doing anything as such. So it is getting blocked just because there is this particle. So initially in the first generation, this thing was happening. In the second generation, by mid 2000s, those nanoparticles or nanostructures that we were using, they have got little bit advanced. Now they are working actively. After being at a particular point, they are doing some action. So nanostructures that react to the environment stimuli. Let's say I give you the example wherein in my body, let's say there is a nanoparticle or nano robot that I have sent exactly in my body when water supply is less, or let's say oxygen supply will be less in any part of my body. Exactly at that point of time, this oxygen will be provided by this nano robot. This can be done. Or I told you about the example of cancer. Let's say there's a patient who is suffering from cancer. So there will be some cells which are cancer cells. They are getting affected. Now when you get any chemotherapy or any medicine or whatever you're taking, now that affects cancer cells, but that affects other cells also. So the person will not feel good as such. Your healthy cells will be affected. So here you can go for precision medicine. Here you can give your drugs or give your therapy to exact those cells which require it. So using this nanotechnology, when we in the second generation, we started using the structures which could react to environmental stimuli. So any body part which requires drugs at which point of time, whenever there is a problem, it will act only at that point of time, not just in a general way. That started happening in second stage. Then third stage, third generation, system of nanosystem. So we're not using one particle, one nanoparticle. Now we are using different 10, 15 nanoparticles, and it's a system altogether. All these systems are integrated, they are assembled, and they are working together. One will do one task, other one will do different tasks, they will communicate likewise. And the fourth stage is something called molecular nanosystems. So at the molecular level, we want complete smart systems. We want nanorobots to do complete tasks on their own. Okay, so smart drug delivery, nanorobots, molecular machines. So this is where we are still working. We are still in this fourth stage of nanosystems. Okay, so this is how we see generations. And to give you some examples wherein we are using nanotechnology for the healthcare. So we are using nanoparticles, carbon nanotubes, dendrimers, nanodiamonds, quantum dots, nanofilms, liposomes. You should at least know these names. Okay, these names you should know that these are part of your nanotechnology. These are applications of nanotechnology. So nanoparticles could be any particle which is of this size, 1 to 100 nanometer particles. If you are using it, then it's a nanoparticle. There are something called carbon nanotubes which we can use in our body. Let's say in my body, as I give you the example that oxygen supply is not there, something is not there. So I want to give that supply, but I don't want to do it using a long pipe. I don't want to put a long pipe in my body or a very larger sized pipe. So I can make a very small tube, very small, so small of this size. I can make this carbon nanotube and I can put it in my body. Okay, so similarly, there are other examples, nano diamonds, quantum dots. All these are just examples or applications of this nanotechnology in the healthcare. So even this last part is done. Okay, so these are all the articles from two themes of science and technology portion. Now, if you have any doubts, please ask, or else we will just wrap up this session. Yes, any doubts? No? Okay. So today, this was our first class and we have covered two themes. In the next class, we'll start with the next theme. So almost 10 classes will be there for the science and technology portion, and we'll be covering substantial portion of your current affairs. It will be revised substantially. Okay, so let's meet in the next session. Thank you so much for joining.